All right, students, you need pages 267 through 271 tore out of your book. We're going to begin topic 5, understanding ratios. And so if you get those pages tore out and get ready, I'll give you a few seconds to get that done. Okay, if you look at the I can statement, it says that I can use a ratio to describe the relationship between two quantities. That means we're going to learn to compare things. So if you look at our picture here, it says a band just released an album that contains both pop songs and R&B rhythm and blues songs. If we look at the picture, it says best of the 90s. Number 1 was British pop, 2 was chamber pop, and you can read through all those. That's the list of pop songs. In the second column, it's R&B, rhythm and blues, and we're going to count to see how many is in each one. So, since they have them counted, we know there's 9 in this column. So I'm going to put a 9 right here. And then if we count these, there's 1, 2, 3, 4, 5, 6. There's 6 in this column. Now then, ratio, there's a good word to use for ratio that you use a lot in English class when you compare and contrast in English class. Ratio means we're going to compare two quantities in math class. So, over here where it says I can, we're going to learn to compare. That's what ratios do. They compare two things. Okay, so you'll have to keep looking at this picture, and I'm going to go down here to A. It says, how can you describe the relationship between the number of pop songs and the number of R&B songs? So I'm going to write down pop right here, and it was 9, and R&B, and it was 6. Now then, this what I'm fixing to tell you is real important because it's going to be this way from now on. We want to describe pop and R&B. So whichever one we say first becomes the first part of my comparison. So it's pop and R&B. So I could say it this way. I could say 9 to 6 pop to R&B, or I could say 9 to 6. This colon means the same thing as the word to. Or I could say 9 compared to 6. Now, in your mind, which one of those looks more mathematical? Well, it's this one written in fraction form. Okay? So, this is a way to write a ratio, this is a correct way to write a ratio, and this is a correct way to write a ratio. Now, let's go back to our reading. It said pop and R&B. So, this is the pop. This is R&B. The first one said, or the one that comes before to or and, is your numerator, and the second one that was said in the reading will be your denominator, or comes after and in this problem. Usually they use the word to. Okay? Now look at part B. It said, how does the bar diagram represent the relationship between the number of pop songs? Here's my pop songs and here's my R&B songs. Well, a while back we learned about greatest common factor. And if you know anything about fractions, and we should because we've been working on them, we know that the greatest common factor of 9 and 6 is 3. So if I take 9 and divide it by 3, and take 6 and divide it by 3, I get 9 divided by 3 is 3, and 6 divided by 3 is 2. So what that means is that there's 3 of these for every 2 of these. Okay? So, this is divided up. Excuse me, I've had a cold. There's three bars here, or 3 spaces here. So to make that be 9, there would be 3 in here, 3 in here, and 3 in here, for a total of 9. Well, this bar is the same size as that one, so there would have to be 3 in here and 3 in here. So that would make this have to be 6. So is that true? Was it 9 compared to 6? Yes, it was. Okay, so for every 3, for every 9 of these, there's 6 of these. Or it's in a 3-to-2 ratio. Here's the 3, here's the 2. 3 bars compared to 2 bars, or 9 total compared to 6. Okay? See how the picture goes with the words? All right, let's go down here to focus on math practices. It says another album has 2 pop songs and 10 R&B. So it's 2 compared to 10. 2 pop to 10 R&B. And they want us to draw a diagram. Well, I know that both of these are even numbers, so I could divide this by 2. I could divide this by 2. My greatest common factor there is 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. Okay? So, whatever size this one is, bar, this one's going to have 5 of them. One compared to 5. There's the 1, there's the 5. So it said draw a diagram. We just did that to represent the relationship between the number of pop songs. Okay, so there's 2 in here, and there's 2, 2, 2, 2, 2. So that's 2 compared to 10, or it's 1 bar compared to 5 bars. So that reduces to 1 to 5. Here it is, and here's your bar diagram. Okay, let's go look at example 1. We're going to learn to write ratios, and we did this on the last problem also. Tom's Pet Service takes care of cats and dogs. Currently there are more dogs than cats. Compare the number of cats to the number of dogs, and then compare the number of cats to the total. So we're going to do cats to dogs, and then we're going to do cats to total. Compare cats to dogs, then compare cats to total. Okay, we're going to do 2 different things. Okay, so there are 14 cats and 17 dogs. It's telling you right here. All right, if we want to do cats to dogs, we can do cats to dogs. We can do it this way. That's one way to write it. We can do cats colon dogs. There's another way to write it. Or we can do cats divided by dogs compared to dogs. There's another correct way to write it, just like I showed you on the last problem. Okay? When you draw the picture, the 17 is a prime number, so there's no way to get a greatest common factor out of there, so you're just going to have 2 bars, and one's going to be bigger than the other one. Okay, and over here in this first box, it explains to you everything that we just said. Okay, so a ratio is a relationship in which for every X units of one quantity, there's Y units of another, as in cats to dogs. A ratio can be written 3 ways. You need to know all 3 ways. Cats to dogs, cats to dogs, cats to dogs, just like they did right here. Okay, now, what do we do when they want cats to total? Well, the cats number didn't change, but the total number is the cats and the dogs put together. So that's how they get 14 to 31. 14 to 31, 14 to 31, 14 to 31. Okay, so we had to add the cats and the dogs together to get my bottom number. Remember, this is cats to total. This one over here was cats to dogs. Now, what's really important about this is you have to read. When you're reading a problem like this right here, you have to read what did they want. They wanted cats to dogs. That's what we did in this right here. And then they wanted cats to total, and that's what we did over here. Okay, now let's go down here to the try it. What are 3 ways to write the ratio of the number of dogs to total? Dogs to total. We want dogs to total. How many dogs were there? 17. 2. What was the total? the total was 31. They just did it right up here for you. So we could write it that way, or we could write it 17:31, or we could write it 17 divided by 31. What are the three ways to write the ratio of dogs to total? We just did it. Next question. Is the ratio of dogs to cats, well, that was 17 to 14, dogs to cats, dogs on top, cats on bottom. Is that the same as cats to dogs? Well, cats is 14 on top and dogs is 17 on bottom. Are those two things the same? No, not at all. Not the same. Now, how do you explain that? Not the same because the ratios are different. The ratios, and the word that we're going to use, the ratios are not equivalent. The ratios are not equivalent. Okay, let's go to example 2. I'm going to use a bar diagram to solve a ratio problem. The ratio of footballs to soccer balls at a sporting goods store is 5 to 3. Excuse me. If the store has 100 footballs, then how many soccer balls do they have? So we can see from the picture that this is 5 and this is 3. But we want to know what an equivalent ratio would be if we change this 5 to 100. Okay? So some of you may be looking at that and going, oh, well, that's 5 times 20 is 100, so 3 times 20 should be 60. This ratio, when it's broken down, has to come back to this ratio. So whatever this numerator is multiplied by to get that, this one has to be multiplied by the same number to get my new answer. These have to be equivalent ratios. Okay, so if you observe that, you know what we're looking for now. All right, so let's go down to the picture. We're going to use a bar diagram to show 5 to 3. 1, 2, 3, 4, 5, 1, 2, 3. 5 of these to 3 of these. That's easy. They're all the same size. Okay, if we use the same size diagram over here, but we want each one of these to have 20 in it. Why 20? Because 100 divided by 5 is 20. We want to keep the boxes the same size. We want to keep the same 5 boxes. So they divided 5 into 100. So now instead of 1 being in each box, you have 20 in each box. 20, 40, 60, 80, 100. Okay, so we've got to do the same thing down here to the green boxes. Instead of them having 1, what will they have? Well, it says over here each box represents the same value, so we're going to write 20. So whatever was in here, this is the same size box as this one was, so this has to be a 20, 20, 20, so 20, 40, 60. Isn't that what we got when we did it up here with an equivalent ratio? Okay, nothing really to work there, it's just understanding. Example 3. Chin can ride his bike 3 miles in 15 minutes. At this rate, how long will it take Chin to ride his bike 18 miles? 18 miles. We're going through 3 miles in 15 minutes. So we've got one bar here that's got equal increments growing by 3 each time, because that's what they told. We know this. We know that. So for every 3 miles, it takes him 15 minutes. 15 minutes for 3 miles. So we're going to break this up into batches of 3 going across here. 0, 3, 6, 9, 12, 15, 18. And then down here, we're going to break this into 15 minutes. 15 minutes, 30 minutes, 45 minutes, an hour. 15 minutes, 30 minutes, and we could keep going. But we want to know, at this rate, how long will it take Chin to ride his bike 18 miles? 18 miles. Well, we come to 18. We come down here. It's going to take 90 minutes. Okay? Now let's do the math. I'm going to go 3 miles in 15 minutes. But I want to go 18 miles. So my 18's got to come up here because I had miles on the top compared to the minutes. I got to put my miles on the top up here compared to X number of minutes. Now then, what do I multiply times this number to get 18? Well, it's 6. 3 times 6 is 18. So I've got to take this 15 and multiply it by the same 6. So I'm going to come over here and say 6 times 5 is 30. 6 times 1 is 6 plus 3 is 9. And I get 90 minutes, which is the same thing they got with their bar diagram. Okay? All right. Let's go down here to the trike. Chen's friend Alyssa can ride her bike 2 miles in 7 minutes. Use a bar diagram or a double number line diagram to find how long it would take Alyssa to ride 10 miles if she rides at the same rate. Okay, so let's put miles on the top like they did. And let's put minutes on the bottom just like they did. And this time, 2 miles in 7 minutes. So here's my starting point. So I'm going to make this 2, 4, 6, 8, 10. Here's my 10 miles right here that I'm trying to find out. And this is every time it's going to take 7 minutes. So this has to line up with 7, and then this will be 14, and this will be 3 times 7, which is 21, and this will be 4 times 7, which is 28, and 5 times 7, which is 35. So this was 2 miles, 4 miles, 6 miles, 8 miles, 10 miles, and then this was then skip counting by sevens. 1 times 7 is 7, 2 times 7 is 14, 3 times 7 is 21, 4 times 7 is 28, 5 times 7 is 35. So it's going to take 35 minutes for her to go 10 miles. So 35 minutes to go 10 miles. Okay? We're just trying to learn how to work with ratios and comparisons in math. Okay, turn your paper over. Key concept at the top. A ratio compares two quantities. A ratio can be written 3 ways. Please, I need you to know all 3 ways. X to Y, X colon Y, or X over Y. Okay? Ratio of oranges to apples is 2 to 3. 2 to 3, 2 to 3, or 2 to 3. Ratio of miles to minutes is 2 to 45, 2 to 45, 2 to 45. 2 to 3, 2 to 45. How did they know all this information right here? They looked at the picture here. We got 2 oranges for every 3 apples. So we could write it this way, or this way, or this way. We looked at the chart and we know it. 2 miles every 45 minutes. 2 miles 45 minutes, 2 miles 45 minutes, or 2 miles 45 minutes. These are answers to what that says. Answers to what that says. All right, let's start with the do you understand? What is a mathematical way to compare quantities? A ratio, and in parentheses we're going to put fraction because we're most often going to use the fraction. A ratio is a fraction used in math to compare two quantities. A ratio, and there's 3 ways to write a ratio, but the one we're going to use the most is a fraction form. is a fraction used in math to compare two quantities? Number 2, what are two different types of comparisons that a ratio can be used to make? Well, let's think back to the dogs and the cats example. We did dogs to cats, we did dogs to total, we did cats to total. Okay, so we can do part to part, or we can do part to total. So I'm going to put over here cats to dogs, or we get cats to total. Or we could do dogs to cats and dogs to total. Part to part is each one. Part to total means it's going to be one of the parts and the other two parts added together. They might use the word whole here instead of total. Part to part or part to whole. Okay? Alright, let's go to number 3. A science classroom has 5 turtles and 7 frogs. What is the ratio of frogs to total? And I'm going to underline what we're looking for. We're looking for frogs to total. So frogs is how many? Let's count the frogs. I see 1, 2, 3, 4, 5, 6. I see 6 frogs. Did I miss one? 2, 3, 4, 5. Oh, 7. Sorry. 7 frogs. And then turtles. 1, 2, 3, 4, 5. Turtles is 5. Okay? Total. This is turtles. And then I want total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total is 12. All right, we want frogs to total. Well, frogs was 7. Total is 12. You can write it like this, or you can write it 7 to 12. You can write it like that, or you can write 7 colon 12 like that. 7 has to come first, 7 has to come first, 7 has to be in the numerator. Okay, number 4. Ty is making trail mix. 3 cups of nuts for every 4 cups of granola. We're going to do 3 nuts to 4 granola. If Ty has 6 cups of nuts, so we want 6 nuts, and we want to know how much granola. Well, what do I have to do to 3 to turn it into 6? I have to multiply times 2. That gives me 6. So if I take 4 times 2, it gives me my answer, which is going to be 8 granola. Or you can draw a picture, whichever you'd like. So he needs 8 cups granola. He's doubling his recipe. Doubling means times 2. All right, we're going to go to number 5. In 5 through 7, use 3 different ways to write the ratio. 6th grade basketball team has 3 centers, 5 forwards, and 6 guards. So this is the information we're going to use for these 3 problems. We want forwards to guards. Okay? We want forwards, which is 5, guards, which is 6. So I want 5 to 6. I want 5 colon 6. I want 5 over 6. Use 3 different ways to write it. Forwards to guards, forwards to guards. Now we want centers to total. I want centers to total. I make me a little note here what I'm looking for. I want centers, which is 3, to total. Well, how many have I got? I've got 6 and 5 is 11. 11 and 3 is 14. So my total is 14. So that's 3 to 14. That's 3 colon 14. That's 3 over 14. 3 to 14, 3 to 14, 3 to 14. Now I want guards to centers. Guards to centers. Guards to centers. So that's 6 to 3. 6 to 3, 6 colon 3, 6 over 3. And you don't have to reduce these fractions when you're making these comparisons like this. All right, we're going to number 8. The ratio of blue cards to green cards is 2 to 5. There are 8 blue cards. Okay, so if there's 8 blue cards, then 8 divided up 2 ways would put 4 in here. 4 and 4 is 8. That's all they've told us so far. But they said the ratio is 2 to 5. But this box is the same size as that box. So there's got to be a 4 here, a 4 here, a 4 here, a 4 here, and a 4 here. 4 times 5 is 20, so there has to be 20 green cards. There's 20 green cards. Once again, multiplication facts come in very, very often. All right, let's look at the next page. We're going to do practice and problem solving. What I want you to work on for the rest of the class period today is just page 271. It's done the same way we just worked on page 270. Make sure you read carefully and you answer the question that is being asked. For example, O plus donors to A plus donors. Where's O plus? You got to use the chart over here. How many O plus donors are there? O plus, there's 90 donors. How many A plus? There's 45. So your answer should be, and you're supposed to do this 3 different ways. So you got 90 to 45. You've got 90 colon 45, or you've got 90 over 45. And you finish this page, and we will continue this lesson with some additional practice tomorrow and work on some vocabulary. Get busy. Shake out the cobwebs after Christmas break and let's go.